Okay, hello everyone, it's Maggie here, and we've had a few questions regarding the noise assessment, assessment 1. So I thought I'd come on and do a brief Zoom meeting for you so you can just get some further information and orientate yourself as to where the data is available. Everything that you need has been made available on Views. To find the information, come in here to the workshop, allow some time for my computer to catch up, and then we're going to scroll right to the bottom. All the information you need is right here once it appears. And don't forget, we've got the little guide for accessing Australian standards too, because you will need the Australian Standard 1269 as part of this report. You might want to read it as a refresher as to how you went about the monitoring and why you might have done particular steps in the order that you did. So what we have here, we have the code of practice, which outlines the what, where, how, why. It's important to understand noise exposure and also methods for preventing hearing loss in the workplace. We have the Australian Standard that establishes the methodology by which we take our samples, we measure the noise exposure, remembering that the Australian Standard has been brought into law under the Work Health and Safety Regulation that actually specifies and calls up this standard. This is the one that you use when you take your measurements to assess an occupational exposure. We have the noise practical worksheet that was handed out. You'll remember this one. It was where you collected and collated your data. It probably looks rather messy like mine. I've also included a clear floor plan for you, so you can upload this into Paint or your preferred graphic design suite, and here is where you'll add those measurements. You'll put in the grid references to the readings that we took, the spot readings, as part of the to do your noise map. And you might also like to put in some of the readings or where the instruments are located to give you greater information on what to do. I'll just pause that for the moment. My apologies for that. So we have the floor plan, which is where you add in all your data. So this is going to become one of the figures in your report that you will be discussing as to what's happening and what may need to be done about it. The noise map readings, another essential part. These are the readings that will go into that floor plan. If you click and open, whoops, not sure what I opened then. I think I opened the wrong one. Aha. There we go. This is the noise map readings. As you see, Group A, refer to Group B. Group B, this is the Monday morning. Here is your readings. And Group C, here is your readings. Remember, we divided the room in a grid pattern. So 1, 2, 3, 4 refers to rows 1, 2, 3, 4 across the front. And A to H refers to the rows going from the front to the back of the classroom. So from the screen desk through to the fume cabinet. So each of those will come a point across your map. I've included the dosimeter results here. This is for your information to have a look at and see how a person's noise exposure may vary over the day. And this is to help clarify you why even though we may have a certain exposure at 85 dB, we actually vary quite a bit in our exposure over the day, which in turn affects our overall noise dose across the day. Other things to look at here, you can see it's quite flat. This is the morning session where you're all in the same session, but then when you moved out to your different activities, we can see some changes across the intensity of the sound that you're exposed to. This is interesting here. If I saw this in a report, I'd discard it because it looks like a classic case of tampering or whistling or something's hitting the microphone. So this result would be null and void. But that's all we're going to do with that for now. So I'll close that off. There's our, just checking I'm on the right screen. Yep, we're on the right screen. Didn't want to have it staring at a black screen. So here's our student noise practical assignment. So again, so this is all the information you have. We have the code of practice that gives you the background, the where's, the why's, the how's, the Australian Standard for the method. You have the noise practical to remind you also how you went about collecting your data, the floor plan to put your information into, plug and play if you like, and your noise map reading, so that goes into there. I've also included a sample assignment. Now, please remember this actually comes from another unit. They do an intensive full-day monitoring of an industrial website. So this has a lot more going into it than your report. So, but I wanted it there to give you an example of just the kind of sections that you might expect to see in a report. So if you come up, so you've got your cover sheet, as always, we have our assignment, you have an open page, so the person, your client you're producing, knows that this is the report, it relates to their premises. So we have an executive summary, which is usually just very short, the what, when, how, where, why, never more than one paragraph typically. You have a table of contents. Sometimes you don't need this if it's a very short report. You have an introduction, what was done and why, aims and objectives of the monitoring, because your monitoring can change. Remember, we discussed at the workshop in the Code of Practice, we take monitoring for different reasons. The scope of works that's being done, the process description, which describes what's undertaken in the facility. Say we're in a lab, so the process description would be that it's a large open plan teaching lab with some pieces of noisy equipment located around. And for the sake of the assignment, you might want to just say it's an 8-hour shift in the lab, because that'll keep it easier to relate back to the standards. Then you have your methods, your results, your discussion, your conclusion, your recommendations, and your reference. So very, very similar to a standard scientific report. We just tweak it more because we're writing as though we're presenting it to a client who's engaged us to come in and have a look and do a risk assessment of their facility to tell them how they're doing and what else might need to be done. But we'll come back to that in a moment, because really with the assignment, we want to start with what's actually required of us. So we'll come into the learning guide. So come back to your unit learning information. Come into our learning guide. This is what you'll be assessed against. So you want to make sure you hit all the target points on this. So here we go. The assessment details. It's a 30% report. It's due on Friday the 27th at midnight, 2,500 words. You'll submit it through Turnitin. I encourage you to put it in through Turnitin early, because Turnitin is really good at helping you identify not just where similarities occur, but it can help you with grammar and other items in doing professional writing. So the rationale is that noise is a hazard in the workplace. It's a physical hazard, and it's a hazard that we're exposed to in every part of our life. We don't leaving the workplace does not mean the hazard disappears. In the case of noise, we continue to be exposed. It's also a serious issue in Australia. It's been identified as a priority work-related disorder in the National Occupational Health and Safety Strategy. So in this assessment, we're basically doing a risk assessment. Now remember, a risk assessment is part of a risk management plan. We look at a particular hazard, we identify where it occurs, what's happening, and determine the likelihood of health risk associated with exposure to that hazard. So in this process, we're using the methods of noise mapping and also taking measurements of those individual machines to determine the potential risk presented to workers in this laboratory environment. So the two pieces of information that you'll find really useful in putting together your data and exploring your data is the Code of Practice, which sets it out very succinctly as to the what, where, how, why of noise, measuring, preventing, and managing hearing loss in the workplace, and AS 1269, the Australian standard, which is very much sets out how we go about assessing noise in the workplace. And remembering that Australian standards can be called up into law, and this is one of them. This is actually called up into the legislation, it's called up in the Work Health and Safety Regulation, and it actually specifies that when you're assessing exposure to noise, it must be conducted in accordance with this standard. So the report that you're discussing, we have as in the example report, executive summary. So just those key points, what you did, what you found, what needs to be done. We had the introduction, so the location. We were in the environmental health laboratory. The purpose of the reason was we were doing a preliminary risk assessment, just because we didn't know what the exposure was like in this place. So it's really much an initial assessment that will guide further works. And we wanted to see what their exposures were and how they related to the Australian legislation. So remembering your Work Health and Safety Act, so we'll come into that. I'll just go over here and we can go directly to Safe Work New South Wales. Stop. And we want the Act. Oh no, we want the regulations. Not in the Act, it's in the regulation. Work Health and Safety, so Safe Work New South Wales. By now I'm sure you're all very, very familiar with this work safety regulation. It's into effect. The Code of Practice also discusses, it'll raise the point, but if you want to go back to the original source, always good to go to the original source, come into your Act, scroll down, we want to go to Part 4.1, noise. So, meaning of noise, exposure standard for noise. So under the Australian, under the Work Health and Safety Regulation, employees, the maximum exposure limit is 85 dBA, or the equivalent 85 dBA over an 8-hour day. So this means you could go lower, but the time has got the time that the worker can be exposed can potentially increase. But if you go higher, then the amount of time the worker can be exposed to that source needs to be decreased. Or you do what the best practice is, which is to keep it as low as reasonably practicable for that environment, and you find ways to modify the noise exposure at the source. We tend to avoid modifying exposure at the receiver because that's harder to do. It's better to control at the source than to go for the receiver, such as PPE. The other exposure standard we need to be aware of is the LC peak. So we should not have a peak exposure of more than 104 dBc. So that's more an impulsive, it's a quick sound like a gunshot. Here is the legislation. This is relating to the fines where a workplace is in breach. It also covers audiometric testing where there's exposure of over 85 dBA. It's recommended that audiometric testing is brought in. Here's the duties of designer, manufacturers, importers and suppliers of plant. So again, here's that low as reasonably practicable. So when you look at some of the sources that we measured in the lab, you might want to think how these sources could be modified to actually lower the exposure in the workplace. So that's the legislation. And the legislation is something that would come into the introduction. Legislative requirements. So when you're discussing the legislation and you're looking at your exposures, then you might also want to come over to the Code of Practice. So this is what we're discussing there before. So here's the standard 85 dBA dosage over an 8-hour day. If you go to 82 dBA, see you're increasing, we drop by 3, you increase by 12. However, we go up by 3, then you reduce the exposure, permissible exposure down to 4 hours. Add another 3 BD, it comes down to 2 hours. See how it just continually halves until at 130 dBA, then it's 0.9 of a second. And that's pain. That's really the threshold there. So if you come through here, this is a good section to look at as you're preparing your introduction. How much noise is too much? Because this sets out the whys and the wherefores into doing your assessment. So that It's a bit on the introduction, and you may like to refer back again to that example assignment and see how this particular student introduced the reader to what was happening and the significance of the work and why it was being done. Then we come to materials and methods. So this is your instrumentation, your sampling method, the AS 1269, and how the data was collected. For this portion, to refresh your memory, you might like to come in here. Don't have to worry about the noise dosimetry. We're focused really for this on the occupational noise measurements and your occupational noise mapping. How was this done? How did you collect the data? What steps did you take? And yeah, as I said before, this would include making a note of the particular instruments. You did the calibration checks. This is that information that you captured here. Remember how I got you all to record the make, the model, the serial number, the calibrations, because these are all requirements that are set out in AS 1269. For more information on that, we can call back into our, where's the code of practice, and you'll find out this will give also more information. So what did we do? We inspected the workplace. We did a regular walkthrough. Do you remember if you could hear your neighbour talking? We were taking notes on the different sources that were around. And we very quickly came to the part where we start to do the risk assessment. So the risk assessment, we looked at the lab, who was exposed in the lab, what were the noise sources in the lab, and we captured all that information. And here's how the noise assessment should be done. So these are the tasks that you were hopefully looking at and gathering the data on whilst you're in the lab, and to create your scenario. Now you can be as close to the scenario as you want for the lab. You can say that it was an 8-hour science lab where people worked and they were exposed to X, Y, and Z, or you can create your own scenario around the sources. It doesn't matter the scenario. What's important is that you collect and interpret the data and that you follow through with the steps of the code. So, I mean, I've called it XYZ to cover up the original lab and the other one, but you might want to call it Gaz's Environmental Lab, or ABC Consulting, or you choose the scenario. So we don't need to worry about extended worksheets, but you will want to look at this section 4.4. What information should be included in a noise assessment report? We'll just go back to keep on track. Come back to the assignment. Nope, that's the assessment. So I want, where is it? Okay, so your materials, your methods, AS 1269, what you did, how you did it, how was the data collected, what did you use? The results. So the results will be your noise map that you collect. So that's example of one. That will be a figure. So this is another building, but if you can imagine this is your lab with your marks, you will add your readings as you took them across the lab from front to back, left to right. And then what you'll be looking for is the hot spots. You'll be trying to create basically like lines through it. It's like a weather map which shows you where problem areas might be encountered. You see here how they've got the 94, so that would be a source there. And as you increase the distance, the exposure goes down. And they actually have a set colouring for this, so I'll come back into your, right? So here's the colouring. So you put in your data points, you work out approximately where the zones combine, and then you simply colour it in the sections. You can do it by hand, you can do it with a computing program. There's a number of different ways to do that. There's even actual programs that will do it for you. So that's one of the pieces of data that will need to be collected. The other data will be a table of your results. So here would be the different instruments that you monitored. Say, remember the fume cabinet. and the time and the levels, comments. You might want to add an extra column. Does this exceed? Does this comply? Is it compliant? Recommendations. Actually, that comes in the next section. So down here, you would have captured all that information. You can put a copy of this as an appendices. So you can refer to an appendices, and that shows the data that you've collected there. Again, you might want to have a look at the example assignment to see how someone's presented that information into a table format, and this will be basically what you present in the methods section. So I've put an example of how you might start collating the data for the map. I just quickly did this one up. It's not done to scale. It's not meeting the actual floor specifications of the data that you collected, but I just did this in Paint. So you put your grid references across. You might want to put in your instruments. Remember how we had the 5 different points that we monitored, which relates back to that other data sheet. You could even put your average levels here, or you might want to put that in a table, or you can refer this to a table. Everyone's got their own way of presenting this data. Present it in a way that makes sense to you and that should make sense to the reader. So if you're looking here, this is the front of the classroom. Here is the fume hood at the back. We have 1, 2, 3, 4, A, B, C, D, E, F, G. So that's where those points collide. And that's why you have the fresh map there. So if you want to use that, you can use that to help generate your own one online. What else have we got? So we had the data points. I'll bring up the example one again. We'll go back into workshop. As you come in here. Sample assignment, and I'll show you how this student has done theirs. They've done theirs, I think, looks like they've been actually done in Paint, because you can use the paint can tippy method to fill in your lines and spaces. So they actually haven't put the points in, rather they've put them in and then covered them over. So you can see they've had some sources in here. They've done a grid pattern and they've taken the line of best fit through there. So there's a bit of, see how there's a solid wall there? That's obviously buffering the noise, so that's isolating this person in here. And you create. So we know then that these could be potentially problematic areas, and that's where you might want to focus some of your controls. So obviously this area of the manufacturing is very quiet. Oh, sorry, I've given you light. Ignore that one. That's because we did light as well in this one. So the warehouse, fairly quiet in here. Here we've got a couple of hot spots, but in all, it's actually less than 85 dBA. So if you had extended work shifts operating here, there might not necessarily be such an issue. Okay, so that's your results. And as always, probably the most difficult part of the assignment we have is the discussion. So this is where you start to look at the levels you got and how they relate to the legislation. Are they exceeding that 85 dB? Did you have any exceedance of DBC? We can safely say that no, we didn't have any over 130. Would have noticed it. This is where you begin to draw together your information from the instruments, the machines, the individual measurement, and also your noise mapping to develop an awareness of potential hazards, noise hazards in that workplace. So you will discuss what the levels were, what people are exposed to, and start to look at the hierarchy of control of how to manage the risk to make that environment a more pleasant one to work in. Remember how a lot of it wasn't over that 85, but it still wouldn't have been a very nice workplace if you had to listen to that for 8 hours a day. So here's where you start to suggest controls to reduce people's exposures. And for this, I would strongly recommend you come back again to the Code of Practice, because it tells you how to do it. hierarchy of risk control. Can you eliminate the risk in any of those places? Is there anything that you could take out? Maybe like remove that radio, pull that out and say no radio. Or can you minimize it? If you can't get rid of an item, like we can't rip out the fume hood, is there a way we can minimize it, make sure it's not left, sash's not left open, keep it closed down so it's in a quieter operation mode? Could we substitute some of the tools? Could we modify them? Could we put put them onto vibration matting to reduce noise from them? Can we isolate them? Can we put it into a room? Could we enclose it in a box? Could we separate from that environment particularly noisy tasks? And from there, then we start to go, as a last mode is when you start to go to the administrative controls in the PPE. So we start with the top. If you refer back to that hierarchy of control, remember that triangle diagram. First, eliminate. Second, we want to isolate and engineer. And then it's, as a last result, really last resort, is when you go to PPE, and that's more when people are mobile. Administrative controls is maybe when you start to limit work shifts in particular areas. You can move people around. Training is another example. And sorry, lost my train of thought there. But anyway, so come back to here when you're discussing what you would suggest and have a read through the hierarchy of control. It's a great document, this, it sets it out. So here's how you could use engineering controls. So use absorbent lining and cushion impact. So we could have put that drill, or maybe not, maybe the bandsaw could have been placed on absorbent matting. The drill work could have been isolated to a separate room. A maintenance program, making sure that you have a good maintenance program so you don't have deterioration of moving parts, which generate and then cause noise and it's not running smoothly anymore. So here's those administrative controls. So notify when working, keeping workers out of noisy areas, signposting noisy areas, providing quiet areas for rest breaks. So with the way that place was running, you definitely want a quiet rest break whether it was working. And then lastly, we come down to use of hearing protectors. If you're going to recommend this, make sure you identify that it would be undertaken in accordance with the Australian standard for use of hearing protectors. So you can look that one up in the Australian Standards website. And remember, the highest weighting is not necessarily the best one because remember, you can overcompensate and then people may be at risk of other hazards because they cannot hear them when they're, such as a reversing alarm on a truck. So here's your hearing protection program, AS New Zealand Standard 1269.3. And they also, what I say, they have everything in here. So they've even given you a guideline for a recommended class of hearing protection. So where we are less than 90, that's where we were, you'd be looking at a class 1. Here's your maintenance program. You've got to have a maintenance program. People using hearing, personal protection must have training, must be maintenance program, and to ensure that they've been using effective. Yes, there is a right and a wrong way to put in hearing in earplugs, believe it or not. Audiometric testing. So again, the rule of thumb is really when you're getting over 85 dBA, that audiometric testing program should be provided. If you want to find out more about that, you can again come out to the Australian Standard. It's part 4, this one. So auditory assessment. That's a hard one to get out at times. Okay, so, and you might want to add as a recommendation also information, training and instruction, which is always a very, very, very good idea. This could be as simple as a toolbox talk in the morning, or it could be a formal program where you bring in certified trainers to do it. Whenever you run a control program, you also have a section there to review the effectiveness of controls and also for if further changes are needed. So here's the section, how to review control measures. It's all here. If you wanted more information on possible ways that you might want to modify those pieces of noisy plant that we observed, there's also a section on that too for you. So use your imagination. The data is all there. You're going to put that into the report and then create your scenario around it. So you may also recognise the noise identification hazard checklist. This was in your notes, so you can add that to your information as well. But come back to this. Please use the discussion board if you have any further questions, and we'll make time to check in on that regularly and help you with that. Thank you. So just to recap, we'll close that off, come back to your assignment. So you'll have the assignment. This will include the executive summary, which is just a very brief overview. You'll have the introduction, why the need for this, what's being done, what is the legislative requirements, the materials and methods, how you did it. Refer back to your handout in the lecture, in the practical activity, Australian Standard 1269, and also there's some more information on that in the Code of Practice. Your results will be your noise map and the readings that you took for the instruments. You may want to put them into one, you may want to present them as tables or separate. The choice is yours. And then you're going to discuss, number one, in relation to the legislative requirements, how did the measurements relate to that 85 dBA 8-hour exposure? Was it higher? Was it lower? Based on your readings, would you recommend shortening the work shifts and then coming through and applying that hierarchy of control, working through what management methods or what controls could be put in place to manage noise within that workplace to make it a really safe, happy, pleasant, nice place to work. I'm thinking a quiet restroom would be really nice in there to get away from all that. And then also your conclusion and recommendations. So your conclusion, did it meet the requirements? If so, why or why not? And your just a few, 3 or 4 key recommendations on what you would do to make it a more pleasant place to work and one that's a safe place to work. So these are those standards. You might want to check out the risk management standard too, because remembering this is a risk assessment, which is part of the risk management program. So this is just one step in that program. And that's why we're doing this, is to give you a practice in how you go about this process. Here's your marking rubric. Again, you'll find more information on here, more clues into the weighting. So if we look at materials and methods, you see we've got instrumentation, sampling method, how it was undertaken. Look at the discussion. So we want information on health and safety implications from the current situation, hierarchy control, and your recommendations. Remember, no new information in the conclusion. The information in the conclusion should already have been covered in the discussion, and you're just pulling out the key points. So we don't have a conclusion that is 2 pages long. We also add a mark for writing skill and grammar, as well as presentation. So we come back through there. So that's your noise report. So remember, all the information is in here. We have the Code of Practice, we've got the links to the standard, we've got the link for your assignment, we have the link to the floor plan, we have a sample assignment, and we have your noise readings. So coming into the sample assignment, we'll just quickly go through that again to cover again, just quickly go over those points that you would have seen in the other ones. So again, your cover sheet, your executive summary, sees 2 paragraphs. They've come up with, so they've suspected that they might need to do hearing protection for these particular activities. They've decided that hearing preservation. So it's just really simply what was there and what do you recommend. It's a standard part of a client report that you'll find. Introduction, so here they've given you an intro to the facility, the location, who was engaged, so you guys were engaged to do it, so students in the class, work and wellbeing. You did the walkthrough survey, the same day's monitoring, so when we're doing the spot points, that's really a walkthrough survey. And then provide insight into noise exposure. They didn't actually mention the legislation, did they, or didn't they? So here's where, they've mentioned the aims and actions. So the aim of the risk assessment was to assess noise exposure at blah, 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 to determine if it presented a risk to the health and wellbeing workers. Specific objectives, here's that 85 dBA. And the DBC, they've missed that one. Scope of works, some people put this in, some people don't. You don't have to, it's up to you. It's just a practice that we do in consulting. Process description, so this describes what the function of the facility was. So theirs was a two-story workshop, yours is a lab, it's a teaching lab. Typically we have Michael, myself, Sue, maybe 3 to 4 staff in there, although we don't normally work in their 8-hour shifts 5 days a week. So that's just capturing the background information, because remembering how people move within that facility will change their exposure to noise and their overall dose during the work day. So methods and measurements, they did a walkthrough survey, they did noise monitoring, A-weighted sound pressure, sound pressure level, L peak, and so this is, you can tell this is older because they've used the New South Wales WHS regulation, so we're using 2017, compliance with Australian standards. So therefore, the person who reading this report immediately notes that if you should have been doing that work, it's been done in a way that follows the legal requirements. They've tabulated their information, so the sound level meter, Brawl and Kerr, model, serial number. They forgot to put their calibrator and the fact that they calibrated it. So that's essential. When was the noise taken? It was taken apart during X and Y time. So if you go back to your data sheet, that data was captured when we took those measurements for each of the individual machines. You'll be able to record the time frame in which the work was carried out. So noise map was carried, taking spot measurements in a grid pattern across the entire facility. They were recorded as 30-second intervals and downloaded to software for preparation of maps. You can put the dosimeter in, you don't have to. There will be no marks deducted if you don't use the dosimeter data. So here's their results. So they've done the DBC, the LC peak, LA equivalent, and they've chosen to just put theirs as a table. So that's their dosimeter results. And the noise maps in this one are in the back, but you might like to add a table in here. Instead of having manufacturer, you have the source. So you might put in, say, source. We had the fume cabinet. We don't have a worker name. It's not good practice to actually mention individual workers. You might have the drill and the bandsaw, and then you can put your, say, comments, reading, and your readings there. So that, and then that refers into your discussion. So again, this is only a temporal snapshot. Yes, that's what we did. We're only providing the data for that day, and it may actually change under different working conditions and even season as well. The noise levels were universally below. So they've changed regulation now. So they were below the regulation. However, as we all observed, there were some different high frequencies and intermittent sources which could create irritation and anxiety in workers. So you can hear they were talking a bit about some of those too, how high frequency intermittent may cause psychological stress. One thing you'll note here is they haven't referenced anything, so please don't forget to reference. We need to support the data and where it's coming from. And then their conclusion indicated did not, however, so there's that however. Although it met that requirement, it could still potentially cause psychological distress. Remember, health and safety is not just its physical health, but also psychological health. So they've made some recommendations based on that. I hope this helps. I'm sorry it's rather long, but I wanted to make sure that you could come back and get some further information. So go away, use your creation, and see what you come up with. Thank you.